Hey guys, it's Miss Nichols. We are going to continue with transformations today. So what we did on Monday was we looked to see what happens when you add or subtract a number to the parent function, which is right here, x squared. And we saw that if you add or subtract, it moves it up, down, or it moves it left and right. And it just depends on where the number is. Remember, if it's inside the parentheses, it moves it left and right. And if it's outside the parentheses, tacked onto the end, it moves it up and down. So what we're going to look at today is what happens when you multiply by something, because we didn't see that on Monday. So what I have here on the screen is basically, this is what we did on Monday, the parent graph. I just went ahead and I filled out this table. If you plug in these numbers into x squared, these are the numbers you get out. And then I graphed it. And we have our parent graph parabola. And I also have it graphed here on the calculator that I have posted for you guys. Remember, this calculator can be found in modules under Digital Learning Resources. It's a Desmos calculator. Okay, so what we're going to do is we are going to look, and we're going to graph each one of these. There's 6 of them. And we're going to see, well, what happens to this graph right here when we multiply it by 2, okay? So let's go ahead and let's type that in right here. So we're going to do 2x squared instead of just x squared. All right, so notice what you get, guys. So the blue one is the new one. So it's a little bit skinnier than the original one. Orange one is the original one. The blue one is the new one. It's skinnier, and what we actually do is we call that a vertical stretch. So meaning it got pulled up vertically. So let me kind of explain to you a little bit better what that means. So if you zoom, I'm going to zoom in on here. There we go. So on the original graph, look at this point right here where my mouse is. Okay, the 0.11. Okay. So what happened is since I multiplied it by 2, now the 0.11 is up here at the point, well, there you go, at the 0.12. So it got pulled up vertically. So it was here, now it got pulled up there. So that's why we call it a vertical stretch. Or if you look here, originally, where my mouse is, right here, this 0.24, if I can get it perfect, maybe, there we go, 24. That point now is way up here at the point, you can see it's going to be 2.8, if I can get it. There we go, 2.8. So it was down here at 4, and it got pulled all the way up here to 8. So, you know, if you stretch something, it gets taller. So that's what we say a vertical stretch is, when the original points get shoved further up the graph. So when we multiplied the parent graph by 2, we say a vertical stretch happened. So what I'm going to do is I'm just going to write the word, and I'm lazy, I just put the V and then stretch. It's a vertical stretch. Okay? So that's when you multiply by 2, because it got taller and skinnier. We stretched it out. So now we're going to look at 1/2. What happens when you multiply it by 1/2? So let me come back to my graph here, and I'm going to get rid of the 2, and I'm going to replace it with a 1/2. Okay. So now you see it got a little bit fatter, okay? Or what we like to think of is the points got shoved down lower. So for example, if you look here at the 0.24 where my mouse is, close enough, 24 right there. Whoop, there it is. That's the original one. Remember, orange is original. Okay, it's the parent graph. Now that 0.24 got shrunk down to here, to the 0.22. Okay, so it was at 2.4, now it's at 2.2. So it got shrunk down. Same thing here. You can see this point right here, 1.1, is now down here at, on the blue one, down here at 1/2. So it was up at 1, now it's down here at 1/2. Okay, so this one is called a vertical shrink because the points got shoved down further. So they shrunk down. It's not taller, it's now shorter. So for this one, I'm going to put V shrink, for vertical shrink. So what you can notice, guys, is I'm going to kind of just give you a generalization here. If you notice the whole number 2, it was a vertical stretch. And then we got this fraction 1/2, and it was a vertical shrink. So let me give you the shortcut here. If the number you multiply by is bigger than 1, it is going to be a vertical stretch. If the number you multiply by is between 0 and 1, then it's going to be a vertical shrink. So if we look at letter C, I'm not even going to graph it, okay? We'll just say the number we're multiplying by is greater than 1, so this is going to be a vertical stretch. Okay? Now on D down here, we're multiplying by 2/3. Now 2/3 isn't greater than 1. 3/3 would be 1, so 2/3 is smaller than 1. So this is going to be a vertical shrink because the number you're multiplying by is smaller than 1. Now on E, we're multiplying by 3.5. I know it's a decimal, but don't worry about the fact that it's a decimal. Just remember 3.5 is bigger than 1, so it's going to be a vertical stretch again. And then on F, be very careful. 5/4, a lot of people go, oh, it's a fraction, so it's a shrink. Be careful. 5/4 is a fraction, yes, but 5/4 is bigger than 1. If the numerator is bigger than the denominator, then it is bigger than 1. This is like 1 1/4, okay? Because 4/4 is 1 whole. So 5/4 is bigger than 1. So this is also going to be a vertical stretch. So don't fall into that trap just because it's a fraction. Okay, you just need to make sure, is that fraction bigger than 1? This one is. Okay, so now what I want to do is I want to look at, well, what happens, it says, what is, oh, that should say what if. Sorry, guys, my bad. What if the number, let me fix that because it's going to drive me nuts. There you go. What if the number you are multiplying by is negative? Because we didn't look at any negatives up here. All of these were positive numbers. So let's see what happens if we have a negative x squared instead of just the regular old x squared. Okay, so I'm going to come here and I'm going to delete that 1/2. Now instead of x squared, which is what the original one is, let's make it negative x squared. So the original one is orange. The new one, negative x squared, is blue. And you can see it got flipped over. So in math, we call that a reflection. And the axis that it flipped over is this horizontal axis right here. Remember, the horizontal axis is the x-axis. So when you multiply by a negative number, that's going to reflect it across the x-axis. Okay? Now, notice I didn't multiply it by a number. I just multiplied it by a negative. So it's not a stretch and it's not a shrink. If it is just a negative, it is just a reflection across the x-axis. So I'm going to come over here and I'm going to abbreviate. It's a reflection over the x-axis. Okay? So what if on B and C, what if it's a negative and a number? Okay? So let's go back to that 1/2 x squared. This one's negative 1/2 x squared. So let me get rid of that negative real fast. I'll show you something. So when it was 1/2, we said the points on the orange graph got shoved down. It was a vertical shrink. So the 1/2 gives it a vertical shrink. But when you put a negative in front, that vertical shrink still applies, but it also is reflected. So you have to write two things when it's a negative and a number. So you've got to say it was reflected over the x-axis, and should be an F. There we go. And it was the 1/2 gave it a vertical shrink. So the vertical shrink happened by the 1/2, and then the negative made it reflect. Okay. So let's go and look at C. Okay, so let's pretend that this was just positive 3x squared for a moment. So let me get rid of this stuff. Let me show you something. So 3x squared, you can see that the new graph, the blue one, is tall and skinny. So like this point right here at 1, 1 is now way up here at 1, 3. So the point got stretched upward. So a vertical stretch happens because 3 is bigger than 1. But what happens when we put the negative out front? It just flips over. So it's still a vertical stretch because the 3 is bigger than 1. But the negative makes it reflect also across the x-axis. So again, because there's a negative and a number, we have to write two things. You're going to write reflect over the x-axis because it's negative. And since 3 is bigger than 1, you're going to put and it did a vertical stretch. So remember, bigger than 1 is a vertical stretch. Between 0 and 1 is a vertical shrink. So guys, let's put this all together with what we learned Monday and today. So we saw this on Monday, except I only gave you an H and a K on Monday, and now I threw in an A. That A is what you're multiplying by. That's what makes it vertically stretch or vertically shrink or reflect. So let's review what H does. Remember, H is what you add or subtract inside the parentheses. If you add or subtract inside the parentheses, it moves it left or right. Remember, when it's in the parentheses, it tricks you. So plus is going to be left, and if it's minus, it's going to be right. Now K on the end, let's review what it does when you add or subtract on the end. If you add or subtract on the end outside of the parentheses, it moves it up or down. Up is plus, down is minus. It's pretty straightforward for K. So remember, H tricks you, K does not. So now A, that's what we just learned. So it says A blank the graph if A is greater than 1. So A, if it's greater than 1, remember we said it's vertical stretch. So I'm going to put it vertically stretches the graph. So A vertically stretches the graph if A is greater than 1. Now, A blank the graph if A is between 0 and 1. So remember, if we said it was between 0 and 1, it's going to vertically shrink it. So I'm going to vertically shrinks. So A vertically shrinks the graph if it's between 0 and 1. And then lastly, if A is blank, the graph is reflected over the blank axis. So remember we said if it's negative, so that's what goes in this blank, the graph is reflected over the x-axis. So then, now what I want to do is I want to put it all together. Okay? So I'm going to write something over here real fast. Okay, remember, I'm going to put H is left, right, just so we can see it. K is up, down. And then A is a vertical stretch / shrink. And it also is a reflection if it's negative. Okay. So we're going to look at each of these problems, and we're going to figure out what these numbers do. So originally we had x squared. That's what we had originally, and on all 6 of these, we've added numbers to x squared, and we're going to say what each one of these does. So if you look at letter A, we have 4x squared minus 5. Well, the 4 on the outside is being multiplied with x squared, so that has to make it an A value. Okay, H and K are going to be added or subtracted. So 4 is multiplied, so it's going to be A. And since it's bigger than 1, it's going to be a vertical stretch. That's what the 4 does. Now, let's look at this minus 5. So this is subtracted, and you've got to ask yourself, is it inside the parentheses or is it not? Well, this doesn't have any parentheses, so obviously it's not inside the parentheses. So it can't be an H. So that means it has to be a K. So that means it moves it up or down. And remember, I told you K doesn't trick you. If it says minus 5, which it does, it's going to move it down 5. So the 4 vertically stretches it, and then the minus 5 on the end moves it down 5. Okay, let's look at B. So this 1/3 on the outside is being multiplied, so we are going to say that it is an A value. And it is between 0 and 1, so that means it is a vertical shrink. 1/3 is between 0 and 1. Okay, now the next one, the +2. Well, that's inside the parentheses, so if you look over here, inside the parentheses is H. So that 2 moves it left and right. So remember, I told you H tricks you. So if it's +2, remember that really moves it left 2. So the 1/3 vertically shrinks it, and then the +2 inside the parentheses moves it left 2. Now let's look at C. So originally we had x squared, and now it's negative x squared. So it's being multiplied by a negative, so remember that reflects it over the x-axis. So that's what the negative does. And then the +1 on the end, that +1 is not in parentheses, so it can't be an H, it means it has to be a K. So that means it's going to move it up 1 because it's +1. So the negative reflects it over the x-axis. The +1 on the end moves it up 1. Okay, we're going to skip a couple of these. Let's just go on to F, and then we'll be done. Okay. So F, let's look at it. F's got a lot going on. So the first thing I notice is this -2 on the outside. This -2 is being multiplied. So first, let's address the fact that it's negative. So negative is going to reflect it over the x-axis. That's what the negative does. But then we've also got to talk about the fact that there's a 2 here. Well, 2 is bigger than 1, and remember, it's an A value because it's being multiplied. And if A is bigger than 1, okay, because we've already talked about the negative, so now I'm just looking at the 2 itself. 2 is bigger than 1, so it's going to vertically stretch it. So that's what the that's what the 2 does. So the -2 reflects it over the x-axis, and it vertically stretches it. Now let's look at -9. That's inside the parentheses, so it has to be an H value. So that's left or right. -9, remember it tricks. It's a big trickster, so put a star there. Okay, -9 is actually going to move it right 9 units. And then lastly, we have a +3 on the end, so that would be your K value. Remember, K moves it up or down, so if it's +3, that means it moves it up 3. Okay, so now what I want you to do is I want you to turn in the number 5. It's 4 of them. I just want you to tell me how each 4 of these were transformed. Was it vertically stretched? Was it reflected and moved up 5? Was it vertically shrunk and moved left 8? Or whatever. I'm just making stuff up. Okay, but that's what I want to know for each one of these. So you only have to turn in 4 problems. When you're finished, just upload them, and that will be your daily grade for the day. All right, guys, I hope you have a fantastic rest of your day. See you later. Well, I know I won't see you later. Guys, this is really sad. I guess I'll talk at you later because I'm not even really talking to you. Whatever. This is so complicated. All right, guys. Love you all. Bye.